Here's the discharger. Everything is working. Got my Goblin battery. This is stick pack number 2. It's the front battery discharging. I'm at 53% right now. It's been discharging for a few seconds already prior to the video starting. The battery did start at 97% according to this. Right now the Arduino is showing 22.01 on the current draw. Don't pay attention to the voltages. I don't have anything over here programmed or trimmed out yet. The balance leads aren't even hooked up into the Arduino, and I'm getting inaccurate numbers, so that's in the process of being fixed. I just don't have the stuff yet. Here's the fans looking down into it. Heat sink. This is my new relay. This is a 40 amp relay. I got a different heat sink. I believe I may have caused my old relay to fail, so I went ahead and got a new one with a new heat sink. This one seems to be holding up. The one thing I did do differently, though, as you can tell, I got transfer grease. I got heat transfer grease on this one. Whereas on the other one, I did not do that. Right now we're testing to see if the relay actually shuts off on its own. I have it programmed so that when the current draw hits 21.15, the relay should shut off. Here's the battery at this point. Now we're down to 22%. Mind you, this is under load. These batteries are 3 years old, so there's going to be large voltage sags because these batteries are pretty much, I don't want to say they're shot, they're still usable, but I'm going to have to take this pack down to about 16% while on load so that it comes back up to about 47% for storage. So right now I currently have the, like I said, I have the Arduino program to show off at 21.15 amps. Because I don't have the voltage stuff set up yet. So I'm monitoring my pack with that EO Sentry. Now we're 21.27. Still on. And it is now off. It shut off the discharge cycle, which is what I was hoping for. Now I gotta try to unplug try and get the load off. Let the pack equalize. So this pack is going to be a little bit lower, it looks like, about 7%, maybe 5% lower in discharge. $41. Let's just let this sit for a little bit. Packs are warm. I'd probably put them somewhere in the 80 degree range. I don't have my temp gun down here. I got it upstairs actually. I was trying to take care of my lizards and I needed to get cage temps. So looks like we're going to be settling out at about 42% at that shut off point. So like I said, I have it programmed to shut off at 21.15 amps. Just to give you an idea why I have it set for amps. So my load bank, let me get my noisy chair over here. My load bank, which is underneath, which has air blowing on it from underneath, and I have air blowing down on top of the heat sink. I went with 5 ohm resistors, which puts me at a 1 ohm load bank, because I do have them in parallel, because of how Ohm's law works and how resistors work when in parallel. So you take the ohm of the resistor and you divide it by the amount of resistors that you have while in parallel, and that will give you your final ohm rating of your load bank, provided that all of your resistors are the same rating. Once you start incorporating various ohm ratings that aren't the same, then that changes the formula a little bit. I don't know that math, so just know that if whatever amount of resistors you have in your load bank, that's what you divide the ohms by that's listed on the resistor, and that gives you your total overall load. Now, because I am running at 1 ohm, that gives me what I would call, or in air quotes, parity in voltage to current draw. So whatever volts I put into it, that's how many amps I'm going to get out of it. Now, my power supply, which the Chargery power supply, the 1500 watt one, 60 amps. If I was to hook this up onto my load bank, you would see that there's almost a 1-to-1 ratio. I actually pull at just like right around an amp less than the voltage. So if I pull 23.7 volts, I'm pulling somewhere around 22.4 amps. Now, the reason for that is because the resistors have a plus or minus on them for accuracy. So you're not going to get exactly, like on mine, I'm not getting exactly a total of 1 ohm. I'm getting a ballpark of 1 ohm. Because keep in mind that there is a tolerance of plus or minus, and I believe these are 5%, so there is a 5% tolerance plus or minus to its listed value. So that's why I'm not getting exactly a 1-to-1, and I have that compensated for in code, which, yeah, I won't go over there right now, but just to give you a quick 10-minute video, how I have all of this. Now, none of this stuff is mounted permanently as of yet. The structure is temporary. I do plan on constructing something that's a little bit more permanent. This is just to give me an idea of how I want it to be built. So, real quick, the fans I have running off of my old power old power supply over here. This used to be my power supply for my charger, and then I converted it over to a boom box. You can't see the speakers because of the wood. There's the speakers. I actually have a car amp inside there. So anyways, right now I'm running off of one of the 12 volt HP power supplies that are advertised a lot on our forum, and so I got two 12 volts and I have a 24 volt output. So I'm using the 12 volts to power the fans, because these are 12 volt CPU fans for cooling CPUs. So I'm running those on 12 volt. I need to still figure out how I'm going to jump down to 12 to 5 so I can supply power, 5 volt power to the things that need 5 volts, like the screen, I really can't do the relay because the relay needs to be controlled by the Arduino. So I'm trying to reduce the current draw on the Arduino, and the reason for that is the 5-volt voltage regulator that's on there, which provides its reference voltage. If I pull too much current off of my Arduino, that's going to screw up my reference voltage, which screws up all of my readings on here. So I either need to supply this with a constant 5-volt voltage reference, or I need to take 5 volts off of here, or take things off of here that are powered by a constant 5 volts, so I don't affect the voltage regulator that's on the Arduino. And chances are I'm just going to go with a steady 5-volt input voltage. I just got to find my step-down converter that I have. I have an extra step-down converter. I don't know where it is right now. This is going to be the balance board, or the board to connect the balance leads into for monitoring the cell voltages. It's just a simple voltage divider. Right now I'm waiting for potentiometers to come in so I can trim out these numbers so that they're more accurate instead of having to do it in code all the time. Jumping into the code to have to change all these numbers is getting rather painful. So to get all of these to read 0, it's getting awfully painful. And then once they read 0, and I know that that works, I then have to get my voltages using something similar to this. So when I plug into here, I can trim it out to be where they should be, and then I can set up safety factors in code that will shut down the discharging bank to keep my batteries from over discharging. So that's what the plan is for the future, but this is it so far.